Okay, so year 10, unit 1, and we're converting between decimals and fractions to convert. Let's see an N in there. Obviously, a decimal into a fraction. We put the digits after the decimal point over an appropriate power of 10, then simplify. Convert the following fractions into decimals. Because there's two numbers here after the decimal point, that means it's going to be 100ths. So that's the same as 54 over 100. They both divide by 2, so that would give me 27 over 50. So converting that to a fraction, we end up then with that. Next one has 3, so it's going to be over 1,000. So it's 347 over 1,000. As we speak, I can't think of any common factors there, so you can maybe get back to me if I've messed it up, but I think the answer to that's 347 over 1,000. I can convert a fraction into a decimal, either change the fraction into equivalent fraction over a suitable power of 10, or complete the division calculation. We've got one of each below here, so it'll hopefully make sense. Remember, 3/4 means 3 divided by 4, so that's an important wee bit. Any fraction in the world ever just means divide, so it means 3 divided by 4, so it means how many 4s go into 3. Obviously, 4 doesn't go into 3, there's not enough of it, and that's why then it is a fraction. But how much of the 4 will go into the 3? Well, the answer then is 3/4, and that's why 3/4 means 3/4. For the first one, we're going to convert into a power of 10, and what that means is we can change this into 100ths using equivalent fractions. I times that by 5, so I'm going to do the same here. So you'll have my equal sign, and I get 35, and that gives me then 0.35. The next one is 5/16, and you can do this for any number or any fraction in the world. That will always work. This one's quite hard to get up into powers of 10, so it's either 10 or 100 or 1,000. It doesn't divide into any of those as far as I can remember, so we're better just doing then a division. So I'm going to do 16 divided by 5. And it'll work for anything. It'll work for 3/4 up there. It'll work for 7/20 if you want to do it this way. Always totally fine. So 16 into 5 does not go. 16 into 50 goes 3 times. 3 16s are 48. So we have 2 left over. So this is 20. 16 into 20 goes 1 time. And there's 4 left over. 16 into 40 goes 2 times. And there's 8 left over. 16 into 80 goes 5 exactly. So that's us worked out. 5 divided by 16 is the same as 0.3125. On then to some recurring decimals, which to be honest is kind of a similar thing. Sometimes we have a decimal that the digits repeat in a pattern infinitely. We call these recurring decimals. For example, this is a third is 0.3, which you can write like that. A dot means that you repeat the digit. When more than one digit is repeated, we put a dot over the first and the last digits, where 1/7 is 0.142857, 142857, 142857. So because it's that bit repeating, we do our dot here and our dot here. Let's take a wee look then at the 6 and see if we can do this. Again, you can type it into your calculator. 1 divided by 6 is going to give you the answer. And we'll maybe look at that in a wee second, but we don't want to cheat, you know, and kind of ruin our fun here. So let's take a wee look. So hopefully then we'll see our pattern from that. 6 into 1 doesn't go. 6 into 10 goes 1 time, and there are 4 left over. 6 into 40 goes 6 times, and there's 4 left over. You can hopefully see what's going to happen here. 6 into 40 goes 6 times, and there's 4 left over. So we've got our pattern. That means the 6 is going to be 0.166666 going on forever. So we put a dot above the 6 to show that the 6 is the number then that's going to be repeated. 2/3, that's one I would expect people to know, but let's just check it anyway. Three into 2 doesn't go. 3 into 20 goes 6 times and 2 left over. 6 times and 2 left over. 6 times and 2 left over. So 2/3 is 0.6 recurring. And 3/7 then. This is one that I like. 3.0000000 should do it, I think. 7 into 3 doesn't go, of course. 7 into 30 goes 4 times, and 2 left over. 2 times, and 6 left over. 8 times, and 4 left over. 5 and 5 left over. 7 and 1 left over. 1 and 3 left over. You can see we've got our 3 here and our 3 here, so it's just going to start to repeat itself again. So we'll be back then to 4, and so our number then 3/7 is 0.42857 Again, you might want to go on and just check it, just because I happen to know it. It will be 4 and then 2 and then 8 and 571, and so it kind of starts repeating there. And just a wee thing that I find interesting about sevenths is it's the same numbers, like 428571 in the same order. 428571. So for 1/7 it starts as 1428571. For 2/7 it starts with a 2. So 2/7 is 0.285714. 3/7 it just worked out. It starts with a 4. And 4/7 it starts with a 5. And so on. And you can work it all out then from there. Anyway, that's how you work out your recurring decimals.